Okay, this one looks like it should be working. And how do I give you a link? Let's see. Right, go live. Settings. Well, I got something here. Why can't I find a link to this video? Stream options. There we go. So it looks like maybe this will work now. I still don't understand why things weren't working today. I tried something different. I thought I had figured out the system, and looks like there's still some problems, but maybe somebody could let me know in Slack or on the chat if you can see anything here, anything, something like that. That would be helpful to know. Yay, looks like it's working. Okay. So, yeah, I don't know. I thought I had figured things out. I see 2 people watching now. I guess maybe the 2 that responded in Slack are those 2 people. So I don't know how to spread the message here, but we should try to share this link with the rest of the people so that they can see if they want to. I'll add a message here in Slack. And yeah. So at least things are up and working now. I don't have a very well planned out sort of agenda for today, but I guess the main idea here is that I can answer some questions. I could go through a few things if it would be useful, and if there's no questions, I think maybe that's what I'll default to doing. But my understanding is that most people are working on these lessons 3, maybe lesson 4, something like that. I know some people are a little bit ahead of that. So I've got the materials available for lessons 3 and 4 kind of easily accessible here. I'm using Jupyter Notebook instead of Jupyter Lab because, of course, Jupyter Lab didn't want to work on my computer 2 minutes before we were supposed to start. But the main topics, you know, we're starting to get a little bit more into these programming topics that are things that are fairly common to all programming languages, but really involve you thinking a little bit more like a computer programmer. And in order for those ideas to work, it just takes a little bit of time and practice with some of these things to understand, for instance, with this lesson on for loops, why it is you would even want to use a for loop. And of course, you know, there are a huge number of cases in which for loops are used in programs, or similar kinds of loops are used in programs. And normally it's because you want to repeat the same kind of operation several times for some data that you're working with. But this part of the course starts to get a little bit more challenging in terms of the concept, because of these things, these sort of abstract ideas. Repeating operations, you could think about it quite easily like the example, I think it's on the Geo-Python course page about, how you start your day, and you do a certain set of operations pretty much most days. You maybe do or don't have breakfast or whatever, but most people wake up and sort of do some regular thing in the morning. So for each day of the week, during the work week, maybe you do the same things, and on the weekend, maybe you do something different. And we could combine, some kind of for loop and one of these conditional statements if we wanted to provide some list of activities during the week. But the main focus, as I said, in this part of the course, I pulled up the materials for the for loops, for conditional statements, and for functions. These are all three kind of very useful concepts in terms of programs, but some things that may take a little bit of time for you to get used to using. In particular, I would say functions. I think students in the past get the idea of for loops. It's not always intuitive how to use them, but normally if you're given some code that has a for loop in it, you're able to understand what to do with that. And I see we've got at least someone in the YouTube chat saying hello. So hello, YouTube chat. Yeah, anyway, do you have any questions maybe as a starting point? Like, it doesn't necessarily need to be about lessons 3 and 4. It could be about something else, although lessons 3 and 4 are the things that I have kind of most easily accessible to me at the moment. But yeah, I don't know, like, do you have any questions? Or if you'd like, I can sort of give examples of some of these different things. Like, we could write some function, we could use some conditional statements, we could kind of come up with some silly examples of things using for loops. But I guess the main thing for me is to know whether people in Slack or on the chat have any questions about this general stuff in these lessons 3 and 4. So I can see some activity here in Slack. So maybe we'll see what kind of questions we have. Okay, so a question is, what is my opinion on nested for loops? Good or bad? I don't know. I mean, I think there's, first off, maybe just to give some context, I think maybe I will create a new notebook here, just an empty one, and say something just in general about the idea of what is a nested for loop. So if we had some list of animals, we can go with my favorite, which is the dog list. And we won't give them very exciting names because I'm kind of not feeling super sharp today, but we'll have dog 1, super dog, and I don't know, amazing dog. Doesn't really matter what we put here. So we've got some list of dogs, and I'm also going to have a list of cats. Similar kind of idea. We could have nice cat, as most cats are, but there are also mean cats, like mean cat, and then there could be hiding cat. That was our cat's default, was to hide. Okay, so we have these two lists, and we could have a nested loop. Let's say we wanted to print out for every dog that it liked chasing every one of the cats. And we could do a simple example here with a for loop that we say for dog in dogs. Dogs is a list, so we can do this nicely like that. And then for cat in cats, because cats is also a list. So we have two loops, one inside the other. The cat list is inside the dog list. And we could now have a print statement that says some dog. So we'll put this here, dog. And it's a character string, so I don't need to convert it to a different data type or anything like that. Chases or chase, yeah, let's go with the present text. Chases, and then plus sign cat. So this is just a sort of shortcut way of concatenating or adding strings together. And so we have this variable dog. It's going to be one of the dogs in the dog list, chases, and then one of the cats from the cat list. And the expectation here is that we should see each dog chase each one of the cats. And that's because of the way we've set up this loop. So we're going to go through here with the first dog, and then the first dog is going to chase cat 1, cat 2, and cat 3, and so on. And so if we run this, we see in the output that dog 1 chases nice cat, dog 1 chases mean cat, dog 1 chases hiding cat, etc., etc. Now, this is one example of a nested for loop. And I would say in general, they're not necessarily a bad thing to use. I mean, of course, you could probably come up with some other way to get these dogs to chase the cats. But what we have here is a situation where we want each dog to chase each one of the cats. And the natural way to do that is to put this into a nested loop so that you go to one dog, let it chase all 3 cats. Next dog, chase all 3 cats. What happens very commonly if we're dealing with like geoscientific data is we might have maybe some kind of gridded data, like elevation data from a DEM, from digital elevation model. And what you might want to do is go along for each row of values at a constant latitude and check the longitude or something about the longitude of the points. And so you go kind of row, starting like loop over all of the rows or all the values in the range of latitudes. And then for each one, you go along the points that correspond in the longitude. If you have gridded data, that's one of the common things that you'll do. I don't have a nice data set loaded up here where I could kind of show you an example of that. But I think using these nested loops, as long as you kind of keep things somewhat understandable, I think it's a perfectly natural thing to do. And in fact, even pieces of rather sophisticated numerical modeling software that I regularly use are built around the idea of having 2 or even 3 major nested loops and a whole bunch of stuff happening within those loops. So the main thing is that you try to keep the code written in such a way that you can understand it. So Python's very nice in the sense that it forces you to indent things, so you can always tell whether you're in one loop or one conditional statement or something like that. You can see that very nicely. And that's not always the case with other programming languages. Python really is strict about the indentation, and that's actually a good thing in terms of making things like nested loops understandable. So that was a good question, and I hope that kind of gave you some idea of how you can use nested loops and why they might be useful. There are plenty of examples when you're dealing with data in 2 dimensions that a nested loop is pretty much the easiest way to process through the gridded nature of 2-dimensional or even 3-dimensional data. So yeah, good question. Are there other questions, either in Slack or on the YouTube chat? I can see both. And yeah, I don't know. Do you have any other things? You got a thumbs up for that, so that's good. Yeah, I think, I don't know what the lag is right now. It seems like I'm kind of a bit ahead time-wise compared to what you guys are seeing. So it seems a bit longer than normal even. And so it'll make things a little bit weird. It might be about, then I'm maybe 10 seconds ahead. But I'll wait just for another moment if there's any other questions. Otherwise, what I can do is maybe just talk a little bit about some other topics just in general, and perhaps that'll spur your memory or prompt you to think of something you could ask as a question. All right, so since I don't see anything at the moment, the for loops lesson, I guess I have the version of it here that is the one that you could kind of fill in as you're watching and following along with the lecture. But the basic idea is, I think, quite simple in some way, and that is that you're just going to go through some list of items, and for each one of the items in the list, you're going to do something. And I've already mentioned this kind of daily example of the things that you do. And the one thing that can start to be a little bit of a challenge with dealing with the for loops comes back to something that we already would have talked about back in lesson number 2 about lists. And that is when you want to refer to the values in a list versus when you want to refer to the index of the value in a list. And that kind of depends a little bit on the situation. I'm going to go back here for a second to our example of the dogs and cats, which is a sort of, the silly example. But one thing you might want to do here is, since we have 3 dogs and 3 cats in the list, that might be a situation that you might want to pair them up somehow. So you say like dog 1 does, interacts in some way with nice cat, super dog interacts with mean cat, amazing dog interacts with hiding cat. And in that case, probably the easiest thing to do is to actually use the index value to find the corresponding cat from the list of dogs. So for example, if we had another for loop here, we could say for I in range length dog. Now what is this going to do? Well, len is going to give us the list length of the list dogs, not dog. That's going to give us the list of dogs, and the length of that list is going to be 3. Range is going to give us 3 numbers starting at 0 that would be equivalent to the index values of the items in that list. So with our one for loop, then we could do something where, like, we have again another print statement, and we could say something like dogs, sorry, I'll put this outside of the brackets, or the parentheses rather, dogs of I. So this is going to be one of the dogs in the dog list. Again, we'll do the plus. And I don't know, some action. We've already had them chase the cats, so how about the growls? I'll go with something scary. Growls at, and then plus cats of I. So here we have a list, and we're going to use this value I that comes from our range function to select one of the dogs out of the list and have it growl at one of the cats out of the list. And in this way, we're just going to not have the dog growl at all of the cats, but only one of the cats that corresponds to the location in the list where the dog is listed there. And if we run this command, what we see is dog 1 growls at nice cat, super dog growls at mean cat, amazing dog growls at hiding cat. So this is an example, because we have 2 lists and we want to refer to items at the same location in those lists, this is a case where we want to use this range function and go over using the index value to get the dog at index 0 to growl at the cat at index 0. Now, if you think about this in terms of ways in which you might interact with geological data, one example for that would be that, let's say you have a list of points where you've collected rock samples or something like this. And for each sample, you have a list of latitude and a separate list of longitude points and a separate list of depths or elevations or whatever. And if you want to go through and make some CSV file or something like that that basically has latitude, longitude, elevation, the natural way to do that is to loop over the length of the lists and take the index for the first item in latitude, first item in longitude, first item in elevation. So distinguishing when you want to do this for I and range thing versus times when you just want to loop like we did here for dog in dogs, it just depends on the situation and the problem that you're solving. In most cases, when I end up using this for I in range, it's because I have something like a list of, let's say, values of x. So in a plot of some function like the sine function, I might have a list of x values where I want to calculate the sine function, and I want to go through and maybe calculate the value of the sine function at each one of those points along the x-axis, and then store that in a certain location in an array of values that would be my sine function calculations. So I don't know, hopefully that's a useful thing. I know in the past there's been confusion a little bit from the students about when to use this for I in range versus just looping directly over the items in the list. I think that's kind of all I have to say about for loops for the moment. How about, any questions about the for loop stuff, or is that reasonably okay? I'm going to guess that probably it's not a major problem at the moment. So as I don't see anything in Slack, what I can do is maybe just also say a little bit about these conditional statements. And the thing here that is a bit challenging is just kind of the logic of how you want to test for certain conditions. So in the toy example that we have here about the weather conditions being rainy, we just check to see, is the weather exactly equal to rain, and then do something based on that condition. So if this condition is true, that weather is rain, then we print out that you should wear a raincoat. Otherwise, we print out that no raincoat is needed. And this test that we're doing here, this should always return some kind of true or false result. So when you do weather equals rain, that should either come back as true or false. And I don't remember whether we showed that kind of thing in the lesson materials previously, but we can do that. We could say, the weather today in Helsinki, it's not raining, might be cloudy. So we can say weather equals cloudy, and that's fine. And then we can store that. And then we can do the test. So weather equals rain. And when I run this, the result I get back is false. So there's two things I want to just highlight here. One is that with a single equal sign, we're assigning a value to the variable weather. We're assigning the string cloudy to this variable called weather. When you have the two equal signs here, this is indicating that we want to check to see whether this name of the variable is equal to, or sorry, not the name of the variable, but the contents of that variable are equal to the word rain. And of course, when you do that test, the result that comes back here is false. And so you get the idea that, when you want to do these kind of comparisons, you always have to have a true or false as the term that you evaluate in your conditional statement. So when you do this if, it always has to be checking to see if something is either true or false. And, if we go to our example here of checking to see whether the weather is equal to rain, that's a natural thing to do. We can also give it nonsensical things to say, like, is weather greater than rain? Python probably doesn't know the answer to that question because it's not something that has an obvious answer. It comes back saying false. I don't know actually how it gets that result. I guess if we say the weather is less than rain, like maybe it would come as true. It says that is true. So it's probably doing something. I don't know if it's checking the length of the string or some other aspect of the string, whatever. The point is that you have to have some kind of comparison here, and usually comparing strings with less than or greater than is not something I would think to do, but you would often do that with numbers. So you can just do a simple example to say, like, 3 is greater than 4, and of course you get back false. You could do the same thing and say 3 is greater than 3. That's also false because the value of 3 is not greater than the value of 3. But if you said 3 is greater than or equal to 3, then of course that condition comes back as being true. So in designing these conditional statements, you have to think about, okay, what do I want to compare and how do I want to do that comparison? Do I want to check to see if something's exactly equal to something? Do I want to check and see if something is not equal? So, you could check to see whether the weather is not equal to rain. And that comes back as true. We had assigned the value cloudy to weather before. So we see weather is not equal to rain. Maybe that's the condition you want to check when you say, do I want to wear a raincoat? You may say, I only want to wear a raincoat if it's actually raining. Otherwise, I don't care. So you could check to see, is the weather not equal to rain? Or if you wanted, you could do it the same way that it was done in the example on the course page, which is to check to see if the weather is rain, and then you wear a raincoat. If it's not, then you don't. So you can do the same kind of logic and tests, sometimes slightly different ways, checking whether something's equal or not equal to another value. And that's the essence of these conditional statements. Of course, you can add in these else-if conditions too. So like if you check to see, like, is it greater than some temperature outside, and make a decision, and otherwise is it greater than some other temperature? I think, again, that example's on the course page that you could consider. And this type of stuff is often used, if you're going through and let's say you're looking for, just some kind of classification you want to do to parts of a landscape. So maybe if it's greater than 2,000 meters, you call it a mountain. And if it's less than, or greater than 2,000 meters, it's a mountain. Greater than 0 meters, it's land. And otherwise, you're going to call it sea or something like that. You could set that up and just say that, like, if our elevation equals 1,000, we're just going to assume that elevation is given in meters. We could do a simple test of if elevation is greater than 2,000, then we could say print mountain. And else if, the elif condition would be that elevation is greater than 0. We would print that this is at least, it's not a mountain, but it's at least land. Otherwise, if the elevation is less than 0, we know that we're dealing with sea. So the very simple case here, of some different elevations that you can consider. We've defined elevation to be equal to 1,000 here, so we kind of expect that we're going to fail this condition that it's a mountain. We should pass, though, the condition that it is land, and so we run this cell. We do, in fact, see that it is land. Now, I want to mention one thing here, and that is that you have to be a little bit careful in terms of how you set these tests up. If we test it first to see if the elevation, so I'll copy this to another cell here. If we test it first to see if the elevation is greater than 0 to determine that this is land, well, we could do this. I don't advise it. And let's just say we flip things here. What's going to happen when you run the code is that the first condition is going to be evaluated if elevation is greater than 0, and we see that it's land. And then we actually never make it to this test of what the elevation would be to be called a mountain. So in our code, if we changed our input elevation value to now be 3,000, this should be a mountain. But because of the way we've set up the order of the tests, we're here testing first to see if it's above 0, and then testing to see if it's above 2,000. We're going to have the problem that this first test will be passed, and that's it. The code will stop checking to see if you meet other conditions. If we flip this back to the original order that we checked for elevation greater than 2,000 first, and then if we know it's not greater than 2,000, it must be something less than 2,000. We can then check for some value that's less than the value for the first test. So the order in which you do these things with this conditional statement logic can start to become important. And we can see here that with this simple example, because of using the wrong order, we've failed to identify this elevation point as a mountain. So just a little note there about the conditional statements, that you have to be a bit cautious sometimes, because you can end up with code that looks like it works, but if you're not sort of checking things carefully, you find out that, well, actually it does run, but it's not working the way that it's expected to work. So yeah, any questions about the conditional statement stuff? I see we still have a few people that are at least haven't closed their browser tab. It lists them as watching. I don't know if they're actively watching, but the Google Analytics information says there's some people still on the page. If there's nothing else with the conditional statement stuff, I will maybe just say a couple words about functions, and then if there's any remaining questions, I can answer those. Otherwise, we can maybe wrap up for today. So functions, I think, are probably one of the more challenging things for people to come to grasp with in terms of the content in this part of the course, but they're also extremely useful once you get the idea. The purpose of the function is basically to allow us to create it's almost like a little recipe to do something in the code over and over in a flexible way. So we start with the example in the functions lesson about this temperature converter to go from Celsius to Fahrenheit. And what you want to do is that rather than putting in some temperature and writing a little code every time you want to calculate the temperature in Fahrenheit, it's much easier to create a function that will do that calculation for you. And when you want to do the conversion from Celsius to Fahrenheit, you simply call that function. And we could make an example function to do that, just to kind of give you the idea, but that's the main point. And so why not? We can just do a simple function example, and I can sort of make a distinction between a couple things in here. So first off, we can define a function, and let's define a function called, let's call it random 100. And our random 100 function is going to take, actually, let's not call it random 100. Let's just call it random. And we're going to give it one number that comes into random. And that number is going to be the maximum number for the random value that we're going to get. Actually, doing a random thing maybe, well, all right. This could be a little bit challenging. So what I'm going to do here is, we haven't really met using NumPy. I think in this functions lesson we do talk a little bit about modules. I'm going to import a module here called NumPy because I want to use this random number generator in NumPy to generate a random number. So if you don't totally get these import thing just yet, don't worry. And I'm also going to add a little thing here called a docstring that just says what this function does, because this is a good thing to do when you create a function. So prints a random number equal to or less than number. So that's what our function is going to do. And to do that, we're going to print out np.random.rand, which is a random number generator in NumPy, and multiply that by number. So this random number generator in NumPy will give us a random value between 0 and 1, and when we multiply that by number, it will give us basically a random number between 0 and this value of number here. And actually, we don't want to print that, we just want to return this random number. So that's our function. We've defined it, it has a name called random, it takes a value called number, and it returns then this random thing times number. So we can define our function. So then if we wanted to use it, we could say random of 10, and we should expect to get a number somewhere between 0 and 10 when we use our random function. Here we get 1.84. If we run it again, 9.26, 0.45, 1.83. You can see basically each time I run this, I'm getting some random value between the range that we're looking at. Now, the thing that I want to maybe make clear is something called the namespace here. So in our function, we have a value called number. And if I wanted to screw this function up and make it not work very nicely, I could define a variable inside the function that is equal to 10. And then I'm going to return np_random times that number. Now, what have I done? Well, instead now of using this value that's passed in when I call the function, I'm overwriting that value with some other value, and I'll show you why in just a second. So we save our function. When we run it like we did before, everything looks pretty much the same. We get this series of random numbers. But now let's say I change this to be, instead of random 10, random 100, and I run it. Now I'm getting values still that are only between 0 and 10, which makes sense because I've put in here this value called number that's equal to 10. If I wanted to, I could now just show you something here. Print out the value of number. And what I see is one useful thing, and that is that number is not defined. And you say, wait a minute, number is defined, but the fact of the matter is that number is not defined in the global namespace where Jupyter is running right now. It's only defined inside of the function. So there is no variable called number outside of this function random. So when we pass this value in, the number that's passed in here is some number we've defined, and then something bad happens here where we replace that number with some value equal to 10, and so the function doesn't work the way it should. The point is that this variables that you define inside functions don't exist outside the functions. There's a reason for that, and it's a very good one, and that is that you don't want to have your functions that might use variable names you might be using elsewhere in your programs to not work because you have some conflict with a variable that's defined elsewhere outside of the function. So this is kind of a protected space that when you go into this function, only variables defined inside the function exist unless you have passed them in explicitly like we do here. The one last thing I want to show about this number thing is I could say number equals 100 and then call random of number. And I still get the same behavior I had before, because what's happening inside the function is that I'm overwriting the value that I'm passing in called number when I use it inside the function. The thing you have to be a little bit careful about when you use these functions is that you do actually recognize that when you're passing things in, these are the only variables that the function will know about. If there's some other value out here, like, let's say we wanted to print out best number. Let's make this best underscore number. When I define the function, it's perfectly fine. It doesn't know whether or not this best number exists. And it's not defined within the function, but the syntax is okay, so Python thinks it's fine. And if I call random with some number in here, I now get a name error saying that best number is not defined, and of course within the function best number is not defined. And even if I define out here best number equals 100, and then I say random with best number and run this. Okay, why does that work? I was expecting that not to work. Okay, maybe I've learned something about how Python operates. I was totally expecting that since we didn't pass best number in here that it would get some kind of name error that best number was not defined, but I don't think it matters that I passed anything here. It's just that best number is defined out here. Okay, well, that's a lesson for me, I guess. That you don't necessarily have to pass in values here to have them be accessible to your functions. That's not something I realized before, I suppose. I wonder if I did something like best number equals 0, change our function up a little bit. So I define best number to be equal to 100, call random with some number, doesn't really matter what. Now when it prints best number, it prints 0. Okay, well that makes sense because best number is set equal to 0 inside the function. Outside of the function, if I print best number, I get my value of 100 that was defined here. So, so the modification that happened to best number inside the function where it was set equal to 0 and then printed, did not affect best number outside of the function. So that, I guess, is perhaps something that's worth noting, that if you modify some values that are existing outside the function inside of a function, that you won't actually affect the values of those outside kind of globally defined things like best number in this case. So, okay, I think that's about all I have time for, unfortunately, today. And I'm sorry, hopefully I've not caused any confusion with that example that sort of went wrong with the definition of best number that ended up working. That wasn't the way I thought things worked in those kind of functions, but I guess you learn something new every time you play around in Python. So I learned a lesson today. Are there any questions? If not, I think maybe we'll wrap things up. I was going to make the suggestion that perhaps next time I will see if we can get people to put questions in Slack in advance. That would be helpful, or in some other way to kind of collect some ideas of things you'd like me to talk about. I can certainly go over the lesson materials and just kind of rehash what's on the course page. But if there's specific things that you want to know, that's very helpful for me to kind of know in advance, so I can be prepared to talk about those things. So maybe a few days before the next time, actually, if we're meant to be next week on Thursday, I've got a time conflict, so we'll have to sort out some alternative for that. But anyway, we'll try to find some way that if you want to give questions in advance on Slack or otherwise, that you can do that, because that would be useful for me just to know what kinds of things are confusing. I know at the beginning of the course, things aren't necessarily so challenging for everyone, but what we can see, maybe things will get a little bit more demanding in the upcoming lessons. So yeah, if there aren't any other questions, I hope that was useful, and we will continue not at the normal time next week. We'll have to make an alternative plan for that, and I'll try to send some messages to the course people and see what the options are. But yeah, we can continue somehow next week. And I'll just wait a second here. Seems some things are coming in Slack, so just make sure there's not any lingering questions. Okay, looks like no. So, all right, yep, thanks folks. Thanks for joining, and we'll sort out a plan for next week. All right.